Okay, AP Chem, we're going to talk today about gravimetric analysis. This is a lab that we would have done had we been in class, but it's pretty intricate of a lab. So, unfortunately, you'll have to settle for the demonstration that I did for you. A 2.00 grams sample of limestone was dissolved in hydrochloric acid, and all the calcium present in the sample was converted to calcium 2+ ions. Excess ammonium oxalate solution was added to the solution to precipitate all the calcium ions out as calcium oxalate. Determine the percentage by mass of calcium in the limestone sample. So this is kind of interesting because limestone, if you'll notice, is not on the periodic table of the elements. Therefore, it is not an element, it is not a compound. So we don't really know what limestone consists of because of the fact that it's technically a solution and it could have a varying level of calcium in it. So the word limestone tells us something about this compound, but it does not tell us anything about the actual percent composition or anything like that. Calcium oxalate is incidentally one of the compounds that does make up like kidney stones. So if you eat too much sodium, so if you have a high sodium diet, you will get a buildup of sodium in your urine and a buildup of calcium in your urine as a result, and it will turn into calcium oxalate, which is a kidney stone. So how do we start these problems? Well, how we start these problems is recognizing that the calcium ions are in solution. Ammonium oxalate is also soluble, it's in solution. And what's actually going to be happening is the chemical reaction that takes the calcium ions that are floating around in solution and reacts them with the oxalate ion, which is also floating around in solution, and gives us a solid precipitate of calcium oxalate. So it says excess ammonium oxalate. Therefore, we know all of the calcium ions will precipitate out, and we don't care about the rest of the ions in the solution. In these types of problems, all we're concerned about is the precipitate. So whenever I do a gravimetric analysis problem, meaning that I'm trying to determine what's in a sample of something by precipitating it out, I always start with the precipitate. So the precipitate in this case is calcium oxalate. And I know that I want to figure out it's asking me to find the amount of calcium in the original limestone sample. So the first thing I'm going to do, of course, is change to moles. That's my first strategy in any problem when I'm trying to go from A to B as far as compounds go. So off the periodic table of the elements, I see that calcium oxalate has a mass of 128.097 grams in 1 mole. Anytime you're calculating something using the periodic table of the elements, you are doing 1 mole. Now I know that I want to do calcium out of here, so I'm going to pull the calcium out. In 1 mole of calcium oxalate, I have 1 mole of calcium ions. Now, this might be a step that you hate to skip, but you can say 1 mole of calcium oxalate has 1 mole of calcium plus 2 ions. This is actually an ionic compound, so we can say the ions make up this compound. The other thing I want to talk to you about is the mass of calcium. Elemental calcium is the same as the mass of a calcium plus 2 ion. Remember, electrons are so small that they do not affect the mass. So losing 2 electrons to go from calcium solid to calcium 2 plus is not going to change the molar mass. So I can now say that 1 mole of calcium 2 plus ions has a mass of 40.08 grams off the periodic table of the elements. So it tells us how much an element weighs, also tells us the molar mass of an ion. I multiply this through and I get that the original sample had 0.7603 grams of calcium ions. Now, in order to get to the percent, I'm going to say my sample, which was 2 grams, had calcium in it and some other stuff. Limestone, again, does not have a consistent makeup. It's a variable makeup, meaning it could be different from sample to sample. So in order to get the percentage, I'm going to say the part that's calcium, this is how we do percent by mass, over the entire sample, which is 2.00 grams of limestone. We'll turn that into a percent by multiplying by 100. So I get 38.0159% calcium. Let's go check on our sig figs. We have 3 sig figs, so I'm going to say 38.0% calcium, like such.